So today I'm going to talk about Invoke DOSfuscation, looking at fin-style obfuscation of command.exe and any argument you can think of that you'd want to run on the command. As I said, my name is Daniel Bohannon. I do check one, check. Low battery. Do we have any extra batteries we can swap out? Check. Keep going. Let's use the handheld. All right. Can you hear me all right? Awesome. So yeah, I do detection stuff with the advanced practices team at FireEye. Previous to that, I was doing Mandia IR consulting. I have an obsession with obfuscation, and so I'm the author of the Invoke obfuscation and Invoke Cradlecrafter obfuscation frameworks for PowerShell, co-author of Revoke obfuscation detection for PowerShell with Lee Holmes from Microsoft, and then Invoke DOSfuscation, which we'll be talking about today. Disclaimer, nothing I'm talking about is pointing to any one or set of customers or clients of FireEye. Most of the stuff I'm talking about I'd never seen in the wild before this research was out, but standard disclaimer. So today we're going to take a quick look at the state of obfuscation, and then we're going to dive into 3 case studies for me to share the impetus that led me to start doing this research. And then we're going to cover 3 sections of obfuscation in command.exe. First is the obfuscation of legitimate binary names. Then we're going to look at a category that I've dubbed insertion character obfuscation. And then we're going to wrap all those things together into full payload encoding and obfuscation. And you can just see how crazy it'll get. Then I'm going to do a demo of Invoke DOSfuscation, which is up on my GitHub. And then at the end, we'll talk about detecting obfuscation. There's a lot of content, but if you miss something or if you don't like the sound of my voice, you can read my white paper on this topic, which is 36 pages of everything we're talking about, and it does go into a lot more detail in some of the in-the-wild cases, as well as a lot of the detection work. So, state of obfuscation. Let's dive right in. Why obfuscate? Well, from a red teamer's perspective, it's a great way to evade rigid detections. And it's typically pretty effective. And if you look around, you can find an obfuscation framework for almost any language you can think of. And I don't really, even though I may be biased, I don't really see this slowing down anytime soon because it's just so easy, it's free, it's effective. From the blue team's perspective, we've actually made some good strides over the past several years in terms of visibility. Things like the anti-malware scan interface, ETW, which is event tracing for Windows. It's been around since Windows, but more recently, a lot of defenders have been using it to get better visibility without having to write kernel-level drivers. There's also a signature-less detection, like some of the data science techniques that Lee and I put into Revoke obfuscation, which is what this little GIF is here. But there's always room for improvement, because no matter what additional gains we as defenders get, attackers are responding, one of several ways. One, they could just choose softer targets, just low-hanging fruit, get the targets that don't have all this visibility. Or they can just go straight and disable that visibility. Disable AMZ, ETW, all manner of anti-forensics. Or they can write their tradecraft or port existing tradecraft into languages that don't provide this excellent visibility. So a lot of the tools that people were using written in PowerShell, they can start to port that to C# and start to lose all the great visibility that PowerShell gave us as defenders and still does give us. So this talk has nothing to do with PowerShell. It's all about command.exe obfuscation. And traditionally, when I talk to a lot of defenders about detecting suspicious command.exe, well, command.exe is super common. It's in everything. Everything calls it. It's running all the time. And most defenders will write rules based off of command.exe being a process and its arguments contains A, B, or C, something like that. But you can also look at it from a parent-child process relationship. So explore spawning command.exe is far less interesting than winword spawning command.exe. But it doesn't necessarily mean it's malicious just because winword spawns command.exe. You can also look at it as a source of action. So command modifying a registry key, or writing a file, or deleting a file, or creating an alternate data stream. Those are some of the additional things you can look at for how do you detect malicious use of command.exe. So how did I get started on this path of this particular obfuscation genre? Well, last year, the very end of June, my manager, Nick Carr, and I, we released this blog post outlining 3 different groups: Fin8, APT32, and Fin7, and some really interesting, unique obfuscation that they were using in the wild during our investigations. So the first one, Fin8, oh, and this is, there's the blog post right there. So the first one is Fin8, a financial threat group. And this was actually de-obfuscated from a macro in one of their payloads. And they're actually setting, the very bottom part is a PowerShell command, which they're setting from Windward in one environment variable called Microsoft Update Catalog. The second environment variable is the middle one, PowerShell dash, which when you pipe something into PowerShell dash, PowerShell will run what you piped in as standard input. So then all you see from Windward is a single child process of command/C echo var1 pipe var2. So you have no idea of what's actually happening if you just look at the command line argument. So it's a really clever way of using process level environment variables, as well as standard input. The second case study is from APT32, also known as Ocean Lotus from Vietnam. And it's been pretty common to see attackers use carrots, which is the escape character for command.exe to break up arguments. But for the past year or so, I've tweeted a couple times and wondered, why don't more attackers use the double quote? Because it's far more effective than the carrot, and most defenders aren't looking for it. Well, APT32 apparently heeded somebody's advice and started using double quotes. In this case, it was to break up defenders' arguments for the regserve32 squibbly-doo discovered by Casey Smith, and they realized a lot of defenders were looking for /i:/HTTP, and so they broke it up first with carrots and then with double quotes. Pretty cool. The last one, this is from a financial group named Fin7, also known as Carbonac. Fin7 and APT32 vie for first place in my heart of the most creative obfuscation. They're really good, and they obfuscate very tastefully. They don't just obfuscate everything. They do certain pieces, and you can really get inside their head and see what they're trying to evade with each layer of obfuscation. This is extracted from a link file. And as you can see with Word application, they have some concatenation in there. Instead of the string eval, they do an ASCII conversion and then add VAL. But the two red boxes is what I really want to focus on. Because when I saw this sample, my manager found this on Wednesday, and it really perplexed me, and I thought about it all that day. Because if you'll notice, there's these @ signs, right? Let's break this down. You have command, it's setting WScript, JScript, blah, 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 into an environment variable X. And then in the middle, it's writing out this, this JavaScript file. Let's ignore that for the time being. But then it echoes X into command. So it's going to run a separate command process that will run the contents of X. But what bothered me was these garbage delimiters, these @ signs. Because if you run WScript with those @ signs in there, it fails. Like, the @ sign is not some forgotten obfuscation character that WScript knows. It fails. But what I noticed is that if you look at the X variable at the very end, Fin7 did something really cool. They actually made space after that variable and then inserted this syntax right here. Now what this does, you put a colon after an environment variable name in command.exe. And remember, this is like command.exe, not like just win10, like for all time command.exe. If you put a colon after the variable name and then you put a string, it will say, I want to find every case-sensitive instance of this string and replace it with whatever you have on the right side of the equal sign. So as you can see here, the whole string is just a single character @, and there's nothing on the right of the equal sign. So it's literally in memory removing the @s, replacing it with nothing. Now when I saw that, I was like, that is tasteful. Man, what finesse. How cool is that? Did you know that command could do that? I've never seen that before. So anyways, we found this sample on a Wednesday. I figured out what that technique was, and so we wrote this blog post on a Thursday, published it on a Friday, and that weekend I went home and started playing around and wrote this little POC called out-fin-coded command. And as soon as I published it, I kind of sat back and thought, I wonder if there's more here. Fin7 obviously knew about this trick that I didn't know about. What other weird things can command.exe support? Maybe this is worth more time. And after about a week of digging in, I realized that this was about to consume the next 9 months of my life, and that's exactly what happened. So implications of this research. These obfuscation techniques will for sure affect static detections. If you're writing detections looking for command.exe and arguments in like run keys or 7045 EID for security or for service creation, it will definitely affect those things. If you're doing YAR rules for batch files and stuff like that, it will affect those things. For dynamic detections, certain of these techniques will definitely affect dynamic detections. So if you're a defender, I don't want you to write off those @ signs were removed when WScript finally ran. That's true in that case, but there are ways that we can keep characters in there. So I'll try to point that out as we go. And basically, we'll be able to take, with the techniques we'll talk about, and with the tool that I released, you can take any arbitrary command for command.exe, like just this echo command, And you can start to add layer upon layer upon layer to get something that looks like that, and it still works. So hang on tight, we're gonna move really fast, and we're gonna cover all these techniques, and then we're gonna stack them all together to build full payload encodings, and hopefully, as a defender, you won't be super discouraged, but somewhat challenged in how you go about detecting this sort of thing, and as a red teamer, hopefully you'll find some of this interesting as well. So, whose binary is it anyway? A lot of defenders will write rules like, if the process name is command.exe and the arguments are A, B, and C. Well, the problem with that is that it's really easy for attackers just to rename binaries. So you can rename a binary to something else, and all of a sudden, the defender's rule doesn't work unless they're looking at internal version information. So I'm not talking about that. I'm not talking about when attackers rename command.exe. Another thing, there's a lot of kind of like command.exe substitutes, like for files or PCA Lua or script runner. So basically, if you have detection that's looking for like windward spawning command, the attacker could just use windward spawning for files to then launch their other thing. So when commands just used kind of as like a shim in between to break up a parent-child process, there's a lot of other things, and here's a good resource for some of those additional binaries. But that's also not what I'm talking about. I'm talking about purely syntactical obfuscation of the legitimate binary name. And the examples we'll look at are the string CMD and PowerShell. One way we can do that is with environment variable encoding. If you have known environment variables, you can use this syntax to basically get substrings out of that syntax. So if we echo program data, we get this, and assuming that C is the path that you have, then if we echo these two substrings of program data, we get CMD. The bottom example is doing the same with PowerShell. Now, the thing about these samples, though, is that when you actually paste this into the command prompt, when you actually look at your process execution events, that obfuscation is gone. It only shows the pure value of that character. And the reason is because when you use known environment variables, not new ones, but existing ones, they will resolve when you run it on the command line. So that really got me thinking, can I find a way to obfuscate these binary names that does not resolve on the command line? So what I ended up coming down to was 3 interesting internal commands. These don't spawn extra processes. These are internal to command: set, assoc, and ftype. Set will show you all the environment variables and their values. Assoc will show you the association between a file extension and an associated type. And then ftype will take that associated type and map it to the binary and arguments it needs to run. So assoc and ftype are very similar. But why did I come down to these 3? At the end of the day, running these commands will produce a lot of standard output that happen to contain the strings CMD and PowerShell somewhere in the output. So how can we take advantage of that? Let's look at the set example. If I do set find string PowerShell, then 2 environment variables come back: the path and the PS module path. If I'm an attacker, I want to use the one that's going to be most consistent on different systems. People's path variables are probably going to be pretty different. But who's modifying PS module path? Probably not many people. So let's just go with that. And we don't have to specify PS module path. We can just say capital P, capital S, capital M, and that will also get us that result. And so whenever there's something like this, where there's a lot of variation, this is actually a screenshot from my source code where I'll just take a huge array of a lot of options and just randomly choose one of those every time I run the code. So when we do this, we'll see this bottom box here is the full value of PS module path. So what we need to do is actually 2 instances of PowerShell, and I want to lift both of those out. So I want to look at the characters that are on either side of these. And in this case, the backslash and the lowercase s are the 2 delimiters that I need to delimit this entire payload on. So if I delimit on the lowercase s and the backslash, it breaks this up into 13 pieces, where I'm interested in piece number 4 and piece number 11, both containing the string PowerShell. So now, how can I do this on the command line using only command.exe? Well, the for loop in command.exe has some pretty cool features, one of them being delimiters. So if I run that set find string PSM at the end of this command, then I say, for the result that comes back, I want you to apply these delimiters and take this token, the 4th token in this case. It will return to me the string PowerShell, and then I just say do whatever the result of that is. So literally execute whatever comes back. And so as you can see in that screenshot, this will actually run PowerShell. Now, why does this matter? Well, are you going to see PowerShell in plain text since it's a separate process? Yes, you absolutely will. But what if this is sitting in registry and you're looking for anywhere where PowerShell is listed in registry? Well, now PowerShell is not listed anywhere. It's hidden in this weird for loop thing. So it's just a kind of an interesting way to layer what you're actually trying to do. So that was binary name obfuscation. Next, let's look at character insertion obfuscation. So as I had mentioned earlier with APT32, they use the caret symbols, which is pretty common. which is the escape character, and if you escape something that has no escapable meaning, the caret is still there. You do have to worry about double escaping, though, when you have multiple child processes. The double quotes are far more effective because you don't have to double escape anything. Double quotes will persist hundreds of child processes down without ever losing their value like carets do. And you have to keep in mind they have to be evenly balanced. You can't have an odd number of double quotes on the command line because command actually doesn't really have a good way to escape. It's like impossible to actually escape double quotes. So pairing them is really important because of the way it kind of joins all the arguments together. Encapsulating parentheses, the only time I've ever seen this in the wild was investigating some newscaster activity. And I don't believe they were doing it for obfuscation purposes, but you can put an evenly paired number of parentheses around commands and some subcommands. And this could definitely break some rules if you're regexing like subcommand A and then ampersand, one or two of those, or name pipes, or vertical pipes, followed by white space and the next command, because you could have parentheses in between that. Leading and trailing special characters. This may be a little hard to see, but that's a comma and a semicolon on either side of command. I've never seen this used before, and I came across this when I was writing a fuzzer script in this research just to say, I wonder what characters I can throw into a command and it still produce a valid command. And so these are the two that it came down to. And so anywhere where you have white space that's used as a delimiter character, you can replace that with as many commas and semicolons as you want. And we'll see why that will really mess with a lot of detections as we get into some examples in a few slides. And then standard input argument hiding, we already saw an example of that. This non-existent environment variables, this is from an old blog post from several years ago, not mine, where you, in a batch file, this doesn't work on the command line, but in a batch file, you can basically put non-existent, like dummy variables all over the place, and they'll just be resolved to nothing when the batch file actually runs. On the command line, they won't resolve, and you'll just have %A% breaking your command. Using custom environment variables as well as existing environment variables, we've kind of already touched on both of those. But collectively, I call this insertion character obfuscation because you can start to insert these in a lot of different places in any command that you have. And in outfin coded command, I basically, as some of the input, you can select whether you want your payload to be run by command or PowerShell. And I included some of these substring obfuscations in that tool. And then someone replied on Twitter and had a full command with just these concatenated substrings. And so in Invoke DOSfuscation, you can add that as an option to basically just substring encode any command or payload that you have. So in the wild, as I started to come across some of these techniques, I started to hunt for them to see, I'm probably not the first person to find this. Is it being used elsewhere that we know of? This is an example of a piece of malware called Devourer, and this was uploaded to VirusTotal in 2012. And this technique goes way back when. If you start to look on forums, people have been doing these tricks for a long time with substring variables. This is another one, JS Batch Obfuscator. This is a tiny project on GitHub, but it's really cool. It's about 2.5 years old on GitHub, and basically the batch file starts with setting a custom variable with the full alphabet, and then the rest of the payload is taking substrings of that variable that has the full alphabet. And we've actually seen some interesting Chinese APT groups using a modified version of this tool and looking very similar. A lot of the differences you'll see are with some of the first couple of commands will have extra @ signs, and then also the payload won't necessarily be the entire alphabet, it'll be just the characters that they need in random ordering. And there's a decoded example right there. This last one, I'm not going to go into too much detail. It's really juicy though, and all the details are in the white paper. This is a tool called batch encryption, where they basically use both known and unknown environment variables. They start with setting an environment variable they call a single quote, that's the name of the variable, and then they set that as some massive crazy value, but they do that with using existing environment variable substrings. Once they set that, then the rest of the payload is just taking characters one by one out of that single variable. So it kind of makes your mind melt when you try to decode that. All right, we talked about obfuscating binary names. We kind of covered this general category of character insertion. But what about the attacker who says, okay, maybe the defenders are looking for a lot of tick marks or a lot of carets, a lot of quotes and these commas and semicolons. Is there a way that I can obfuscate my payload without using any of that? The answer is yes. And I chose this as an example. The portion on the right, just a netstat command, that has no importance other than it's just something simple. But the left side of the command, if you're a defender, then this should send chills up your spine because seeing comspec variable sitting in the registry run key or as a service is a big red flag. Metasploit is one of the first ones I at least saw using it, but /b, c, start, b, n, this together is like never good. This is always bad news. So I use this as an example to show this can actually be obfuscated in some really weird ways, and so it itself is not a silver bullet. So what are these things? Well, ComSpec is the environment variable that points to the full path of command.exe. B, C, start, B, min, there's the expressions there. A lot of times when tools use a lot of flags, sometimes all those flags aren't even necessary. So what if you as an attacker just started removing some of those? And what if you as a defender didn't check to see, are these required? So how can we obfuscate ComSpec? Well, there's two things we can do. One is going to our environment variable substring, right? So the value of ComSpec is 27 characters long. So we could do something like this and say start from the 0th character and just go outwards to infinity, or start from 0 and go forward 27. Or you can use negative indexing and say start from the end, but let's go back 27 and then go out. And so these all resolve to the same value. And you don't have to stick with 27. You could use leet as your number if you want to, and it will still process that just fine. It never goes past the bounds when you start. Environment variable substitution is similar. Remember, this is what Fin7 did. They basically said, take all the @ signs and replace them with nothing. Well, you could take values that never exist and replace them with doesn't matter what, because they're never going to affect the value. Or you could do something like actually changing backslashes to forward slashes, and it's going to run just fine. So let's choose 2 of those and just kind of keep those in our sight as we keep going. We can also, I don't think this should break anyone's defenses, but you can randomize the casing of the environment variable. You can add a lot of white space in interesting places. This actually does change the behavior of the bottom example, but it doesn't matter because we didn't want to change it in the first place. And then you can explicitly sign integers. I don't know if you've ever seen a +0 or -0, but it shouldn't be happening on a command line. It is an interesting indicator in looking for how people are signing stuff that doesn't need to be signed. So let's just replace that with a bottom one. Now, a really important point here is that context is crucial. If you're a red teamer and you take this command and you paste it into services or registry run key or something like that, it will not work. And here's why. Is that this crazy substring and substitution stuff, it only makes sense in the context of command.exe. But when you're running something as a service or run key, it doesn't know what the context is yet. The only reason %ComSpec% works is it's literally like a find and replace for command, and the operating system knows that, but it can't handle this. So in that case, you start with a legitimate command.exe without this crazy obfuscation, but then the rest is fair game. But if you're running it in command.exe or in a batch file or something like wscript.shell, it understands that context. So it's something important to check. So for the rest of the arguments, we can randomize the case. We can actually remove white space between almost any argument we see. So who's looking for, as a defender, space/b space? Because this will burn you right here. Another interesting thing is that you'll notice between our ComSpec, which is command, and the very first argument of /b, there's 0 white space in this. But when you look at the process execution logs, or when you query a running process, the operating system adds a white space. So to make it more interesting, now I could have a rule that 100% detects something statically, like in registry or in event logs as like a service creation, but will fail in the dynamic data because the operating system actually adds that white space in there. So it's really important to test against all the different data sources that you have. We'll just reorder ANO to NOA because it doesn't matter. So we remove white space. We can also add a lot of white space. We can then add in all those commas and semicolons. Wherever white space is a delimiter, we can add as many of those as we want. We can then add carets of several different layers. Now if we run this, the process execution goes from bottom to top. You'll see all the carets are highlighted, but in the second command, where there were 2 carets in the original command, there's only 1, because it's escaping itself. That's why when you have many child processes, you have to factor in every layer of escaping and double the number of carets. But you'll notice this highlighted blue portion. Whenever you see command followed by 2 white spaces, /s space /d space /c, 0 space, double quote, then a space, and then something, this is actually an artifact of the operating system when you run subcommands or pipe content into other binaries. Why does this matter? Because you can write really specific detections based off of those leading arguments and then something else. We'll touch on this towards the detection section at the end of this talk, but there's a lot of it in the white paper as well. But just something to keep an eye on. Now, findstring and netstat are our final processes that run, but what happened to all the obfuscation? Yeah, the casing and the white space is there, but what about the carets? What about the semicolons and commas? Well, none of those characters actually work with netstat or findstring. They don't know how to interpret those characters. So is there a character that it doesn't matter what binary we're running, that it will still persist into its arguments? The answer is the double quote. And another reason why I love it so much is that it works in places that none of the other characters work. So we put our paired double quotes into the original command, and you'll see they follow all the way up into all the child processes. So in writing this was insanely frustrating and complicated because in doing the PowerShell obfuscation development, I had access to the language tokenizer, so I could basically say, hey, in this whole script, these are the commands, these are the strings, these are the arguments. With command.exe, there's none of that. So it was really, really frustrating, and I call this my tiniest violin slide because I'm trying to seek a little bit of sympathy, but not really. But it was a very interesting challenge to try to figure out how to piece all this stuff together with all the layers and have it escape properly. And it definitely is a product of a lot of late nights and tears and coffee. So I kind of go back to the question of some defenders might say, well, why does this matter? Okay, so if the only special characters that can persist in the child processes are double quotes, as a defender, I'll just, let's say, remove double quotes before I apply my detections. Well, I would argue it's important to detect obfuscation in and of itself because that tells you something. That tells you I don't have to care about the intent of what this command was. It's obfuscated, so someone didn't want me to know about it. It immediately becomes interesting. But there's a lot of commands an attacker could do that never create a child process out of command.exe. How about some of these? If they're spawning commands that are running this content but it's all obfuscated, I would want to know if an attacker is sinkholing my security cloud product by dropping something in my host file. That's never going to spawn a child process. You'll just see one blurred, obfuscated command. So I still think it's important to detect obfuscation in and of itself. And the added benefit is that all that time you put into detecting it on your endpoints, you can then apply that in YAR rules, snort signatures, and start to find more samples in the wild and static sources without ever having to run it dynamically. So the very last part here, again, if we're an attacker and our defenders are looking for all these characters and we don't want to put all these crazy characters in our command, is there a way that we can obfuscate the entire payload without using these special characters? And in all my research, I basically kind of boiled it down to 4 different categories of doing this. The very first one is concatenation. And this seemed to make the most sense because it's kind of one of the easier things to start doing. So if we have command /c netstat ANO, fun fact, you can change that tac ANO to /ANO. And it's not just with netstat. As a defender, you have rules that are looking for WScript with /no logo, because that could also be -no logo, or it could be // no logo. PowerShell, if you're looking for -e or -ec, -en, the 16 different ways you can write encoded command, an attacker could just use a / encoded. Would that get by your detection? Or with redserve32, all those slashes can be dashes, and on top of that, the URL, instead of forward slashes, can be backward slashes. Some things like PowerShell can actually take forward and backward slashes in right beside each other when you're doing URLs. So are we taking those little things into account because those will burn us as defenders? Anyways, that was just an aside. So let's set our netstat command into a custom variable called com for command, and then let's echo %com% just to make sure that the value looks right. Well, if we just echo that, it actually doesn't show us the value at all. In the first one, it just shows %com%. That's because a custom environment variable created in a command session doesn't automatically expand. So 2 ways we can expand it are the very bottom. We could just create a new child process and then echo it, or we could use the call internal command, which will expand this environment variable in this session. So that's the one we're going to go with. We're going to put that call in our command, and now when we run it, it actually executes the expanded environment variable contents. So now, instead of just putting it in a com, let's put it in 3 variables, com1, 2, and 3. And then let's call the concatenation of com1, 2, and 3. Now, an interesting thing here, these are screenshots from Sysmon. If you're using Sysmon for any of your data, you may want to look out for some updates because if you'll notice, the parent image command line makes sense. But the command line one, it doubles up the percents. Anywhere where there's 1% in the original command, they have 2 here. And this is actually a really big problem because there's an escaping bug in percent in Sysmon. And so I first came across this about almost 2 years ago, and reached out to Microsoft twice about this. And so hopefully they'll be getting it fixed at some point. But basically, if you're using Event Viewer or PowerShell's get-when event, this mis-escaping of percents can actually result in some pretty erroneous data, as well as hiding certain events. But regardless, the raw data actually has 2% wherever there's 1. So if you're using it as a data source, you're going to have to make sure all of your logic is looking for 1 or twice as many percent characters. And that's just a blog post I wrote on this bug and kind of some of its implications. So know your sources, test your tools. So we can also set our substrings into a final variable, just called final. and this is our payload. Now, there are 5 different kind of categories built into the tool, into Invoke DOSfuscation to execute code. The first one is this. If possible, let's just use the call command because we don't have to spawn a separate process. However, if some of the values in this variable are like the vertical pipe or some other special characters, the call command actually doesn't properly resolve, or it properly resolves it, but in this context, it gets really, really weird. So in that case, we'll just spawn a new child process and either say command C environment variable or pipe environment variable to command. And then options 4 and 5 are the exact same, but they're with PowerShell. So if you want to use Invoke DOSfuscation for command.exe stuff, it's all yours. If you want to actually run command.exe and put PowerShell input and have it eventually run by PowerShell, then Invoke DOSfuscation will handle the layers of PowerShell obfuscation wrapped inside the layers of command.exe obfuscation for the final execution. So as an attacker, we just accomplished our goal, right? We are able to concatenate a command and obfuscate it without using any special characters. But if we wanted to be really evil and have fun, we could add all those things back in. Randomize the case, remove white space, add it. Let's add some commas and semicolons, carets, and then parentheses. And this command still works perfectly fine. We stack all those pieces together. When we run this, it's just a single child process of netstat ANO, which again, some people may be like, okay, well, I'm still going to see netstat ANO. Well, true. In this case, your actual payload is running another process. But you can use paired double quotes and get around that. And so now the arguments are going to have those double quotes. What if we want double quotes that aren't side by side? What about when our input command has double quotes around a string? This is actually insanely difficult and was a huge problem for me in this research because you can't put those double quotes non-adjacent in the original command. That actually doesn't work. So the way that I came up with to get around this is a kind of a 4-step process. First, wherever we want a 1 set of double quotes, non-adjacent, I'm going to change it to 2. Then I'm going to create a variable, and I'm going to set the value of that variable to be double quote, double quote. Third, for our final variable, I'm going to be a little fin7 here and use that string substitution. I'll say, all right, take that value, but before you execute it, take every double quote, and replace it with just 1 double quote. But I can't put 1 double quote in here because then I'm off balance on double quotes. What to do? Well, since I have this quotes variable, I can take a substring of that in memory, which is just 1 double quote. So in the command, I've evenly paired double quotes, but in memory, I don't. However, this doesn't work because the percent signs in the quotes variable messes up with the percent signs in the other variable. So this was really frustrating, and it got me thinking, is there a way I can expand a variable in command without using percents? The answer is yes. If you're running Vista or later, you can use this Vista flag. Now, when you use this, you can actually use exclamation points instead of percents for your variable. So now, exclamation points inside of percents don't collide with each other, and in memory, 2 quotes resolve to 1. Boom, our command works without adjacent double quotes. This got me really excited. Now, I have to be honest, that was kind of a troll. It actually does work, but there's no such thing as a Vista flag. If you look at Command's help menu, there is, however, a /v::on flag, which is for delayed environment variable expansion. What I found, though, is that v::on works, as does any substring, as long as it's not v::off. And then because I'm really curious, I found out that anything, like literally almost anything, will work as well. So you can put insane amounts of information. As long as it starts with a /v, it's just going to be /v. And for environment variable names, instead of com1, 2, and 3 as an attacker, we could just use 100% special characters as the environment variable names. Or we could use differing amounts of white space, starting with 1 non-white space character. So you can get really dirty if you want to. So dude, the defenders in the house are like, you call yourself a defender? What are you doing this for, man? You're making our jobs difficult. Well, I started here because we'd already seen attackers baby steps of this in the wild. In a lot of malicious link files, attackers will concatenate the string PowerShell to kind of evade some static analysis. Here's another example, but then they have some garbage variable highlighted in yellow. And then the third one is also similar, but they basically take the concatenated variables in blue and then set that into another variable in green and then execute that, which is the path to PowerShell. So basically, attackers have been taking small steps in this just for 1 string and a command, but we had never seen a full encoding of payloads like this in the wild before this research was published. So I would say that's the extent we'd seen concatenation in the wild was, again, like in malicious link files, and it was just for the string PowerShell. But we'd never seen it on the full payload. The next 3 techniques I'll talk about are things we've never seen in the wild before this research. And when I say that, what I mean is that for the 9 months of this research, I was hunting across internal data sources, public data sources, sandbox reports, file repositories, and endpoint detections across over 10 million endpoints as part of my day-to-day job of looking for this stuff, and I found 0 of it before we released this. So, concatenation was number 1. Number 2, we're going to look at the power of the for loop. So remember before we used the for loop for some of the binary name stuff? Well, if you look at the v-on description in commands help menu, it says the variable expands, syntax expands at input time, which is quite a different thing when inside of a for loop. Quite a different thing is like the understatement of a century, because you can do insane stuff with a for loop. So let's go back to our netstat example. Make sure we add in our /v for delayed environment variable expansion. Another fun fact. Since attackers like to rename binaries, I don't like to have binary names in any of my detections if at all possible. So I like to use /c as kind of the anchor for command, or like /k, some of the other ones there. But when you actually look at commands man page online, they leave out one, which is weird because they have it further down in the documentation. For compatibility reasons, /r is the same as /c. I've never seen /r used, but you best believe if I'm a red teamer, I'm going to start using this sucker all the time, because a lot of defenders are looking for /c as the anchor. But you can totally replace that /c with a /r. Now it works. The way I remember that is CRV. C and R are the command line arguments, and V is for variable expansion. This is also a tremendous troll opportunity, because in addition to be able to put any characters after the V that you want, it actually lets you do something like this. You can put any characters you want before a /r or /c. What about this? What about this command C echo path? If you're an analyst scrolling through events and see this, someone's trying to find the path variable, right? But what about all this white space and this netstat command way, way, way down there? \c has 0 meaning. /c or /r is what actually has meaning. So when you run this, it's actually running this command way down at the end. So pay attention to your horizontal scroll bars if you're a forensicator, because the actual payload could be way down at the end. Anyways, I digress. For coding, for loop encoding. Let's set the unique characters. So we have netstat ANO. Let's take the unique characters and set it in this variable unique. Then let's create a for loop. And we're going to build out the indexes of every single character in the for loop. And then we're going to end with some other character as kind of our bookend. So then for every iteration of the for loop, we're going to take the substring of the unique variable of the index value, and we're going to append it onto this new final value. And then, if we hit that bookend, we're going to call and execute the payload we created in memory, reassembling character by character. And there's an example of that working. Now, this has a lot of standard output that never actually hits the command line, but if you're capturing the standard output, it does have a lot for every single iteration of that for loop. Now, if you want to increase the level of obfuscation, you can start to put extra characters in those unique characters and then update all the indexes in the for loop. And Invoke DOSfuscation will, if this is the option you choose, it'll also let you add in all the characters we talked about before. So you can take your command, randomize the case, remove white space, add white space, commas and semicolons, carets, parentheses, and you can do explicit signing on all the integers. So it gets pretty crazy. Another troll opportunity is in the tool, you can actually set a custom message in the unique environment variable. And then any characters that you still need in the payload you actually want to run, it'll just add those on to the end. So I thought it'd be nice. You know, as defenders, we enjoy good humor, and so when attackers kind of brighten our day a little bit, like not with anything mean, but just kind of like lyrics of a song, here's a great opportunity right here on the command line. So for coding was number 2. Option number 3 is reversal, and it's very, very similar, except it's using this /L in the for loop. So instead of having to have this massive array of all these indexes, you just have the end index, the beginning index, and the decrementer or incrementer between the two. So in this case, we've reversed netstat ANO, and we're decrementing each value and adding it in. You can also add garbage characters, etc. For all of the for loop stuff, when you have equals equals, that's actually doing a literal string comparison of the string of a number to the string of another number. But you can also use the integer, the compare op operators, equal, less than, greater than, equal, greater than, and all these options are randomly selected every time you run the tool. Now you may wonder, why do we have this, this weird substring on our final variable? Well, the reason is because in the for loop, that's the first time we use the variable final. So the very first time, it actually interprets that as exclamation, final, exclamation. So that's actually part of our value. So we need to chop that off. And the tool will do that either by doing a positive index, a negative index substring, or doing a replacement option which is actually using star. So when you do string substitution and you start with a star, that means find the first example of this string and replace that and everything leading up to that with whatever's on the right side of the equal sign. The last one is fin coding. This is fin style encoding. And basically we're going to take just going to randomly choose letters to swap out. So let's take every T and replace it with a capital Z. Let's then replace the capital Z in memory with lowercase t and put that in sub 1, and let's call sub 1. Let's go back again. Let's replace the A's with 7. We're going to add another command to replace 7s with A's in memory, and then we're going to put that in sub 2, and we're going to call sub 2. We go layer upon layer upon layer and stack these orderings. And this is essentially what I wrote in the crappy little POC last June, except in the POC, I didn't know the things I knew after this research. So for example, I didn't know about /v, so I didn't know how to expand variables in the session. So I created a new child process for every substitution. So that tree was like command, 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 pretty noisy. So I had a lot of commands. I also had a lot of escaping of ampersands to be able to make each ampersand only resolve on that layer. So we had 1 layer, 2 layer, 3 layer. There were a lot of carrots. All right. Let us do a demo. So Invoke DOSfuscation, if you've ever used any of the other obfuscation tools I've worked on, you know I'm a big fan of animated ASCII art. And so this is just a little fun DOSfuscation going on of obfuscating this command. And the menus are very similar to all the other tools. You can just hit tutorial or help and kind of get some help along the way. But basically, you're able to set your command or set the path to a command, and then you can also set the final binary to be command, PowerShell, or nothing, and it'll be command by default. So the first section is binary, and this is just producing an obfuscated syntax to produce a string PowerShell or command. So in this case, it's using concatenated substrings. This one is using the for loop with all the extra stuff added. I basically made all the obfuscation kind of simple, like 1, 2, or 3, low, medium, high, because there's like over 20 different options of obfuscation in every single function in this project. So as a defender, though, I wanted to make those more usable, and I'll show you how I did that in a second. Encoding is the environment variable encoding, so you can set whatever command or commands you want. In this case, we're doing ping 8888. And then you can always do show and see what command you have set, what options you've run. Then you can do environment variable encoding like that. Again, 1, 2, and 3 is going to be more or less environment variables, as well as additional white space and explicit signing. And if we run it, we can see it resolves correctly to ping 8888. But the real meat of this are the last 4 payload encoding things we just finished going through, and that's in the payload section. So for this, let's set a larger command. Let's set a PowerShell command. So set command, PowerShell command, and then set final binary to be PowerShell. So it handles both layers of escaping. And we can go to show again and see we've successfully set our command, and our final binary is going to be PowerShell. So let's do concatenation, and we'll do option 1, and it will do basic concatenation with no extra crazy characters, and we can see that it works. Options 2 and 3 will introduce more crazy characters. So if we do 3, it'll get a little crazy. We copy that to the clipboard and see that it still works. I'm going to fast forward just a little bit. One thing I wanted to do to kind of test myself. All right. So the last one was just basically stacking all the PowerShell obfuscation layers and then DOSfuscation. So anyways, I'll skip that. Don't use this for evil. Detecting DOSfuscation, all these details are in the white paper, basically looking for these special characters in different places, looking for the SDC, the standard input artifacts, IFOMO, the fear of missing out. So if you're a defender, this is the last slide. I released the full test harness for this framework that I used for developing all my detections, and I have over 4,000 test payloads, the obfuscated versions in text files, as well as Sysmon EID1 and security EID 4688, so you can start to basically build your detections without having to run any code. So main takeaways: attackers love obfuscating stuff, it's effective. Command has crazy obfuscation capabilities, and defenders have to match attacker creativity with our own layer or level of creativity. It's not easy, it's very hard, and that's why I'm always happy to help people if they have questions. So thank you so much for your time.